Hi, this is one of my favorite things to teach. So this is called composition of functions. Say composition of functions. All right, we're gonna show some work in here, but I might add to it. So composition of functions is when you have one function inside the other function. So we're going to take something and replace. So normally it's f of x, but we're actually going to take another function, g of x, and put it inside. So one function, F-U-N-C-T-I-O-N, inside another, A-N-O-T-H-E-R. Okay? You can also say that the output of one becomes the input. Okay, the key here is always evaluate from the inside out. All right, here we go. And I love using a table. Here, it's so much fun, and we see it a lot in AP Calculus. Up here are x values from -3 to 3 integers, and then down here we have f, g, and h. So if you see f of 1, so f of 1 is equal to what? 4. And what about h of -2? H of -2, -1. That's how we're going to read this table. Find each of the following composite functions values based on the table of values. Are you ready to rumble? Here we go. Actually, A, B, C are warm-ups. So these are not composite functions yet. Our composite functions begin on E. So let's just do a warm-up to get ready to use this table. So -3 times h of 0. So here's h. H of 0 is +2 times g of -3. G of -3, -2. Whoops, that was fancy. -3 times 2 times -2. Answer? Let's do it. 2 times g of -1. So 2 times g, -1, 7, all over f of -2, 3. H of -2. Oops, I didn't finish. Good morning. We'll leave it like that. Yeah? 14 over 3. H of -2. H, -2, is -1. Okay, you should feel like this is familiar. This is the same math as when we were finding values off of a graph. Remember, we were finding y values off of a graph? Instead of having a graph of f, g, and h, we just have a table of values, okay? Answer 20. Okay, careful here. This is a dot, so we're going to multiply h of 2 times f of 2. And if you're bored, just wait. On E, it's going to get exciting. H of 2. H of 2 is 0. And what's f of 2? F of 2 is 3. What's 0 times anything? 0. All right, ready to have some fun? Okay, here's the key. What's the key to this? Reread your notes. Okay, the output of the first one becomes the input of the outer one. Okay, so what's inside? F of 2. So this will become h of, what is f of 2? F of 2 is 3. So 3 is the output for f, but now 3 becomes the input for h. So now find h of 3. That's your answer. Isn't that fun? Okay, let's do it again. This time g's on the outside. So start with the inside. What is f of negative 3? 0. F of negative 3, 0. Now find g of 0. Try again. G of 0 is negative 2. Okay, listen up. This is where students get confused. Composition, say composition, is not multiplication, okay? Does it kind of look like multiplication? It kind of looks like h times g, but it's not. This is what h of 2 times f of 2 would look like if you were multiplying the values. So it's not multiplication. We got to go from the inside out. All right, I want you to try. You try this row, because I think you could do it. You try. All right, how'd this go? G of negative 2. What's g of negative 2? 1. H of 1, negative 3. F of 3, inside out, so f of 3 is 2. G of 2, 5. I agree. So what's h of 1? Negative 3. F of negative 3, 0. Okay, so now we have a triple composition, a function inside a function inside a function. All right, so you still go from the inside out. 1, look at that silly equals sign in the wrong spot. So what are we going to start with? F of 2. So f of 2 is, find f of 2, 3. What are we going to do next? G of 3. G of 3 is negative 3. And h of negative 3, 1/2. And we're going to keep going. Okay, inside out. So f of negative 1, f of negative 1, 2. H of 2. Are you wondering if you have to show all this work? You do have to show all this work, okay? So you have to show yourself plugging in each term. G of 0, you can't just write equals, 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 okay? Everything I'm showing is mandatory. What's G of 0? Negative 2. All right, G of negative 3. Negative 2. What do you find next? F of negative 2, okay. F of negative 2 is 3, and G of 3 is negative 3. Okay, here's some review. Ready? If k is 2x plus 10, then for what values of x is k equal to this? So if k equals 2x plus 10 and k equals this, then we're going to set 2x plus 10 equal to this. That's what, if k is equal to two things, then we're going to set them equal to each other. So 2x plus 10 will equal f of g of h of negative 1. F of g of h of negative 1. All right, what's h of negative 1? 1. I just said you have to show all this work, and now I want to skip steps. But g of 1, now 0. And what's f of 0? Okay, I'll show all my work. F of 0, we said, is what? Okay, now solve for x. K equal to x plus 10 and k equals this, so that means they're equal to each other. All right, steps to solve. Can you solve for x in your head? what would be the first step? Subtract 10, and what number would you get? Negative 14, and then what would you do? Divide by 2. So x equals, sweet, and then divide by 2. All right, same thing over here. We're going to have the absolute value of 2x minus 3 equals f of g of negative 2. F of g of negative 2. Ready? G of negative 2 is 1. F of 1. If it were a negative, what would we write? We would write no solution, because remember, an absolute value can't equal a negative. But now that it equals a positive, we could say 2x minus 3 equals 4. This is what I meant when I said this is review. And 2x minus 3 equals negative 4. And then solve each one. Try it in your head, and then write it down. So 4 plus 3, 7. 7 divided by 2, 7 over 2, right? And then when we add 3 over here, we get negative 1. So 2x equals negative 1, and x equals negative 1/2. All right, let's turn it over. So now instead of using a table, we're going to get our answers from the graph. Look up here, ready? These are review. Let's do the composition. So I'm going to skip, I want you to do these on your own, but I don't think you need my help. Ready, get set. What is f of negative 1? You have to practice going back from each graph, this graph to this graph. So what's f of negative 1? So then we have g of negative 3 like that. Okay, now this is g of negative 3, so we're not going to look at the f graph, we're going to look at the g graph. You guys, this is like a mathematical principle where you have to figure out which one to look at and then make that decision. So g, anytime you see f, we're going to look here. Anytime you see g, we're going to look here. G of negative 3. G, x value is negative 3. What's the y value? Negative 2. And that's our answer. Fun? G of 0. Here's 0. What's the y value? 2. F of 2. So now, what we're saying, this 2 was a y value. So the output, the y value for g, now becomes the x value for f. So f of 2, look on the f graph, when x is 2, we have a y value of also 2. Okay, f of negative 2, go back, f of negative 2 is negative 1, so I'm replacing f of negative 2 with negative 1, because they're equal. Now I'm going to look on the g graph. When x is negative 1, the y value is 3. Isn't this fun? All right, I'm actually going to go back and do these, because I think I want you guys to practice these on your own. This video seems like it's going on for a long time. Okay, negative 3, this is going to be times f of 2. F of 2 is 2 plus g of negative 3. So this is kind of practicing looking at both graphs. G of negative 3 is negative 2. So we have negative 6 plus negative 2 equals negative 8. Anytime you add two negatives together, it's a negative. G of 3. G of 3 is 1 minus f of negative 1, f, negative 1, y value, negative 3. What happens when you have 1 minus a negative? Comes plus. 1 plus 3, 4. G of negative 2, g of negative 2, what's the y value there? 0 times f of 3. F of 3. 3 is 3, which is 0. All right, so you guys finished these. Won't it be fun?